Welcome back. This is Mrs. Rubright with Algebra 1 Honors, and today's lesson is 3.1, Graphing Relationships. Alright, so the outside temperature varies throughout the day. The graph shows the outside temperature for a day at one location from midnight to midnight. Okay, segment 1 shows the temperature from midnight to sunrise stayed consistent. So from midnight to sunrise, it stayed consistent. That's why it's going to just be straight. Okay, it's staying constant. Describe what segment 2 shows. So segment 2 shows from sunrise, right after sunrise, it started to do what? The temperature started to rise. After sunrise, the temperature started to rise. It makes sense, right? The sun comes up, the temperature rises. Based on the time frame, give a possible explanation for the change in temperature represented in segment 2. The sun came out and heated up the air, like warmed it up, right? Like the temperature goes up because the sun came out. Due to the sun's heat, right? Due to its rays, the temp went up. Which segment of the graph shows decreasing temperatures? Give a possible explanation. So where is it decreasing? Where is it decreasing? 4 and 5, right? So 4 and 5, it could be a cold front. It could be a cold front that came in, and or the sun is setting. Right? As the sun goes down, the temperatures drop. Explain how the slope of each segment of the graph is related to whether the temperature increases or decreases. So if it's increasing, it's going to have a what? Has a positive slope. And when it decreases, it has a negative slope. Right? And then just to show you guys, so this is positive and this is negative. And if you put vertical lines on it, positive is going to be a backwards N, where negative is going to make an N if you put those vertical lines. N for negative, right? Does that make sense? Do you guys see that? How this is part of the N for negative? Where positive is a backwards N, it's positive. As time goes on, you're making more money. As time goes on, it's getting warmer, right? As time goes on, you're losing money. Your Toys R Us, you're going bankrupt. As time goes on, the temperature drops. On 3 days in September, Atlanta received the same amount of rainfall. On September 8th, it rained very hard during the morning, but then rained less and less as the day went on. On September 19th, it rained steadily all day. On September 27th, it rained lightly during the morning, but then rained heavily the rest of the day. Match each day's graph with the correct graph. Okay, so this is the rainfall and the time. So the rainfall just keeps going up and up and up, right? It just keeps gaining. Here, the rainfall in inches and time slowly going up. So let's see. Steadily rained all day. It rained lightly during the morning, and then rained heavily the rest of the day. That looks like this one, right? We still have 10 minutes, guys. We're good. Over here, let's see, so steadily all day. And it rained very hard in the morning, and then rained less and less as the day progressed. So that's going to be that one. Right? It's steadily raining. Your inches are just steadily going up. Does this make sense? Mm-hmm. Okay, so we're going to write here September 19th, September 27th, and September 8th. Describe the rainfall represented by graph A. So by graph A, which was September 19th, right, it rained steadily all day. So the total rainfall increased steadily throughout the day, right? The total rainfall. The total rainfall increased steadily throughout the day. For B, describe the rainfall represented by graph B. Okay, so in B, it rained light in the morning, and then it increased, and then it started raining heavy as the time went on. So the total rainfall increased slowly throughout the morning. Then it continued increasing throughout the rest of the day, but at a much faster rate. Describe the rainfall represented in graph C. The total rainfall increased quickly throughout the morning. Then it continued increasing throughout the rest of the day, but at a much slower rate. Determine which graph represents each day's rainfall and write the dates under the appropriate graphs. So we already did that. Reflect. Could a graph of rainfall throughout a day ever slant downwards from left to right? Explain. We're saying the rainfall going downwards. How would that make sense? We can't start with a ton of rainfall and then decrease in the number of inches, right? Because as the rain is falling, your inches are going up. How many inches has it rained? It's not going to be raining 20 inches and then going down. We're not talking about a drain on the road, so the inches of water that's been rained is or we're not dealing with the evaporation of it. We're dealing with total inches that came out of the sky. So you can never have it decreasing, because it's the same thing as a distance can't be negative because you're going a positive distance, right? You can't rain negative inches where it's decreasing. So no, if the graph, I have 5 minutes, guys, slanted downward from left to right, it would mean that the amount of rain was decreasing throughout the day. The rate of the rainfall can decrease, but the amount of rain can only stay the same or increase. So the rate can change, right? Like it can rain like harder or softer where it's drizzling. The rate can totally change, but the total amount that it has rained cannot decrease. All right. The pool in a community park is being filled for the summer. A water truck arrives early in the morning, but no water is put into the pool for 1 hour because a small repair must be made to the pool first. The spigot on the water truck is then opened partially to add water gradually to the pool during the next 2 hours. Sketch a graph showing the height of the water in the pool over the first 3 hours that the truck is at the pool. Okay, so for the first 3 hours, it says no water is put in the pool for the first hour, none. And then it's open partially over the next 2 hours. Right, so something like that. I guess it should be a straight line, so just like a small slant. Okay. The workers determine the repair they make to the pool is working, so they completely turn on the spigot and continue filling the pool. How do you think this will affect the water level of the pool? The water level will continue to increase, but at a faster rate. Consider your answer in B and sketch the graph of water during the first 6 hours. So, first hour, nothing. Next 2 hours, it went up a little bit. And then they turned the spigot on a lot, right? So now it's going to go like that, right? Because they had it on a little bit. They had it on nothing at all, a little bit, and then a lot. So it's going to be a steeper slope, right? Or maybe I could have gone more like that. Something like that, right? All right, so suppose the second water truck arrives at the end of 4 hours to also add water to the pool. How do you think this will affect the water level of the pool? Do you think it'll affect the water level of the second truck for the same type as the first truck? All right, so the water level, don't pack up till I tell you guys, in the pool would increase at a faster rate if the truck were the same type and size as the original truck. The water level would increase twice as fast. That's a great place to stop. Oh, how would your answer to 3A affect the graph? So the answer to 3A would affect the graph. The part of the graph from 4 hours to 6 hours would be steeper. If the second truck was the same as the first, it would be twice as steep. And that is where we are going to stop for today. Have a great day. Make sure that you do your homework on pages 119 and 120 in your workbook, as well as page 161, 6 through 33, multiples of 3. Have a great night.